Hello, in this video we are going to learn about solving rational equations. This is different from the stuff we've been doing previously because it is solving rather than simplifying, which is what we were doing before. So here's our first example. So if we have 5/12 minus 1 over 2x equals 1 over 3x, we're going to figure out what x is. First thing we want to do, because we're dealing with fractions here, is find the least common multiple. To refresh your memory, that's just the smallest number that all of these could multiply by something to get to. Okay, so just looking at the numbers, we have 2, 3, and 12. 2 and 3 and 12 are all factors of 12, so 12 will be the biggest, smallest multiple. And these two also have an x, so we're going to need 12x. So the LCM, in this case, is 12x. So what we could do with that is, just like in the previous section, we could turn all the bottoms of these fractions into 12x. So to do that, I would have to multiply. Let me clone this. I don't like to mess with the original equation. So we could multiply this by x over x. We could multiply this by 6 over 6, and this one by 4 over 4, and then we'd end up with 5x over 12x minus 6 over 12x equals 4 over 12x. And so now we can combine all the tops, and because we have a common denominator. But an alternative to that is, so let me get rid of all this stuff. Okay, so let's say, using the least common multiple, instead of finding a common denominator, we multiply everything by 12x. Alright, in this case, the 12x distributes to each of these terms here, and so we end up with 12x over 1 times 5 over 12 minus 12x over 1 times 1 over 2x equals 1 over 3x times 12x over 1. So when we reduce all these, so this 12 and this 12 go away. 12 and 2 reduces to 6. The x's reduce away. 3x reduces 12x to 4. And what's cool about this is we get 5x minus 6 equals 4. Obviously, the cool thing about doing it this way is there's no more fractions. And when there's no more fractions, it's just going to be a lot easier. So again, to get rid of the fraction, we found the LCM, least common multiple, and multiplied everything by it. So from here, it's pretty simple. When I add 6 to both sides, I get 5x equals 10, and when I divide both sides by 5, I get x equals 2. Naturally, you're going to want to check your answers here. So 5/12, let's do it over here in red. So we'd have 5 over 12 minus 1 over 4 equals 1 over 6. So if we used common denominators, we could get 5 over 12 minus 3 over 12. That's going to be 2/12, which is 1/6. So x equals 2. Success. Alright, so using that technique, finding the LCM and then multiplying everything by it, I'm going to have you solve this equation and then put your answer in for the form question number 1. Keep in mind that all we're doing here is finding LCM and multiplying fractions, so it's nothing new. You just have to figure out what the LCM is. So here's your question, and we'll move on to another example. So we have 1 minus 1 over x equals 12 over x squared. Again, the LCM is what I'm going to find. So the LCM equals, this one is just a 1, so the LCM is x squared. It's the smallest thing that is a multiple of everything here. So if I multiply everything by x squared, I'm going to end up with, so we have x squared times 1, that's easy, minus x squared over x equals, and then these will go away, leaving us with 12. And x squared over x we know is just x, right? Okay, so where do we go from here? So from here we can use the techniques that we learned in the last chapter, which would be factoring, quadratics, and zero product property. We could also use the quadratic formula. We could use square roots, but not in this case because there's a b value. So let's first set it equal to 0. So x squared minus x, subtracting 12 from both sides. Factors of negative 12 that add to negative 1. Remember, factors of c that add to b give us x minus 4x plus 3. Using the zero product property, we know that x minus 4 must equal 0, or x plus 3 equals 0. So if we add 4 to both sides here and negative 3 to both sides here, we know that these are our two possible answers. So we can check those. Let's see. So I'll check 4 first. 1 minus 1/4 equals 12 over 16. So 3/4 equals 3/4. That worked. Now I'll use negative 3. So 1 minus 1 over negative 3. So essentially makes it just plus 1/3. So let's do that. 1 plus 1/3 equals 12 over 9. So 1 and 1/3. Yep, sure enough, those work. Okay, so what we did here is we essentially did the same thing as we did here, found the LCM, multiplied to get rid of the fractions. Then we went a step further, and using the zero product property and factoring, we were able to solve this equation. So that's awesome. We're using stuff from like 3 different chapters all in one problem, and really working through a lot of great algebra here. Alright, let's try, oh yeah, here's your practice problem. This is for the form. Solve this one, put the answer in form question number 2. Okay, here we go. We have 2 fractions equaling each other. This one's actually going to be probably a lot easier. We know from way back in the day that if 2 fractions are equal, that's a proportion. And to solve proportions, we can use cross products. So cross products, remember, is just when you multiply the diagonals together and set them equal to each other. So 4 times x plus 1 is going to equal 3 times x plus 2. And if we distribute, we can get to a point where we can combine like terms. So if I subtract 3x from both sides, and also subtract 4 from both sides, kind of doing 2 steps in one here, I'm going to get x over here, and I'm going to get 2 over here. So x is going to equal 2. And we want to double check that. So 4 over 4 equals 3 over 3. That's true. Easy. Okay, so in this one we just use cross products, a little distributive property, and combined some like terms, and we got the answer. So on form question 3, I want you to tell me the answer to this equation. For our last example, we have this proportion here. So again, we can use cross products. Alright, so there we go. And I want to multiply diagonally, and the products are going to be equal to each other. So I have x minus 4 times x minus 2 is going to equal x squared minus 4 times negative 2. Oh, let's put that negative 2 up front. Negative 2 times x squared minus 4. Alright. There's a couple of things we can do here. Since they're already since this is already factored, that's nice. Let's factor the one on the right and see what happens. And we could probably have done this earlier, but this should work just fine. We have a difference of squares here. Okay, so if I divide both sides by x minus 2, these will essentially go away, leaving us with, let's move this down here, x minus 4 equals negative 2 times x plus 2. So I can use the distributive property. Let's see, negative 2x minus 4. And then we can add 2x to both sides, giving us 3x minus 4 equals negative 4. If I add 4 to both sides, I'm going to get 3x equals 0, and now I know that x equals 0. Now remember from earlier in the chapter when we were doing restrictions, now that we're solving equations, that becomes more important, because let's pretend for a moment that we got one of our answers was x equals 2. Although that didn't happen, if it was one of the answers, when we go to plug it back in, we would realize that 2 minus 2 is 0. And that would mean the bottom of this fraction is 0. And so that would not be an acceptable answer. So keep in mind when you're checking your work, you will sometimes get a solution that, although works mathematically, when you plug it in, the bottom of your fraction becomes 0. So that is not a solution. So you got to make sure to take that away. All right. Thanks for watching.